Hi! So today we're going to be talking about borrowing money, which is the 9.4 in our textbook, our Hawks. And this unit is, again, it's like 9.2 and 9.3 in its difficulty level. A lot of it is knowing how to plug stuff into the Excel or your calculator, or strategies by plugging in formulas by hand. Now, there are a few things to go over first. There are these three formulas that we deal with. Again, you will not have to memorize these. You just need to know how to apply them. Now this one that is R equals, the R basically stands for months. How many months? It's the equation is trying to figure out how many months it will take before, for you to pay off your credit card debt. This is probably my least favorite equation or topic that we're dealing with in this whole chapter, because there's not an Excel function for it, and it's pretty complicated to plug in. But we'll go through how to do that, and hopefully you'll understand what's going on. So the second one is this one, the monthly payment formula for fixed installment loans. This is basically almost exactly the exact same as our last payment formula when it comes to typing things into Excel. Now, obviously, they're different, but this is in regards to paying off debt instead of earning interest on like investments or whatever. And if you remember in the last video, or if you weren't there, I was confused for a little bit when plugging things into the Excel spreadsheets. So you had like the PMT, and then you had like the rate, and then you had the NPER, NPER. Now, I got confused and said that the payment one had a negative in front of it for the 9.3. Now, that was not true for 9.3, but that is true for 9.4. You can see here, it's to the negative NT power. And so when you plug in the number of periods, because this right here is basically your number of periods number, that will be negative. Be sure to totally pay attention to that. In your Hawks tests or assignments, you will probably, you'll be given the relevant formulas for the problem that you're on, and it's always good to check what they give you. Now, this last one is the maximum purchase price formula. It basically helps you figure out how much, what is it? Obviously, I guess it's what the name says, what the maximum purchase price for something is. Typically, you'll see this in story problems that have to do with houses. If you have this much of a down payment, and you pay this much, excuse me, and you pay this much per month, how much do you, what is your maximum price to purchase a house? And this formula is nifty for that. Now, in the 9.4 exercises that we'll be going through, and in Hawks, the majority of your problems, unless you get something different, but I'm pretty sure that the majority of your problems will be dealing with this payment formula. And I picked out some of the other two, but really they're not very frequent. So first I'll do those other two problems, and then I'll move on to the payments. So this question says, hold on, let me just move some stuff down really quick. Okay. All right, so this question says, you have a credit card that has a balance of $4,760 at an APR of 12.99%. You plan to pay $300 each month in an effort to clear the debt quickly. How many months will it take you to pay off the balance? For these problems, I like taking out what the problem is giving me, what information we have, and what information we're trying to find. I do this for every single problem that I work on, but it's especially useful for this one to do on paper and to write down what each thing might mean. So we have our balance of 4,760. Whoops, I forgot, that's a 0. And this is basically our future value or our amount, our FV or our A. We have an APR of 12.99%. I'm going to write that in decimal form. So 0.1299. We have 300. Oh, and this is equal to our R before I move on. We have 300 each month. And when you hear something like you pay 300 each month or each quarter, that's going to be your payment. And you hear the month, that will probably give you something like a 12 to deal with. And we can assume that this is maybe N. And we want to know how many months it will take to pay off the balance. So if we go over to our formulas, we have our, we'll cross out anything that doesn't have some of our variables in it. So this monthly payment formula, it has a P, and that could be something. This one doesn't have a P or like a V or an A, so we don't need the maximum purchase price, and it's not asking for that anyway. We already know what our payments are, so we don't need to use this. We are looking for month, number of fixed payments. Oh, wait, hold on. Number of fixed payments required. Oh, wait, hold on. Yeah, okay. I know that it's tricky because it says number of fixed payments required to pay off credit card debt. Basically, the reason why I said it's a monthly payment is because a lot of times you'll see problems that are saying that you have monthly payments. So basically, I called it like monthly payment because we were because each month you pay something in a lot of these story problems. But it's not always monthly. It could be quarterly payments, number of quarterly payments, number of monthly payments. So like months or how many quarters or whatever. But I haven't seen it in any other format other than months. So this one is probably our go-to. Now, this part gets kind of annoying and tricky. So let me set up Excel and this. Whoops. Hold on. So I can have them side to side, so I can show you as well as keep an eye on the equations. So, okay, so now that I have that set up, we will look at our information. So, like I said, the R equation, the number of fixed payments required to pay off credit card debt, it does not have a function in Excel. You're going to have to either do it by hand or by calculator. And since Excel is a calculator, it has calculator functions, I'll do it in Excel so you can see what I'm doing. So first, before I even start, I put a parenthesis over the top. I probably over parentheses, but I really think that it's important to make sure that you have an appropriate amount of parentheses, just so it doesn't mess the calculation up. So then I type in negative, log, and it gives me the log function in Excel. And then the number, so 1 minus R over N, which is going to be 0. What was it? Let me double check with that. Yeah, 1299. 0.1299. And then divided by 12, because it's monthly payments. And then we will do times, so multiply, and then another parentheses, because we're catching that parentheses, times A, which is our amount, which is the 4760. So 4760. And then divided by payments, which was 300. And then close that parentheses, and then close that parentheses, this parentheses here, and then we'll close it one more time because we had one around the log. And then I will divide, and then I will open a new parentheses and do log. It's not negative this time. 1 plus, and then R over N, which was 0.1299 divided by 12, close parentheses, enter. And a lot of times I type it in wrong, and it looks like typically their proposed solutions are correct. So I get 17.5. Now, this one is a little bit weird because it says how many months will it take you to pay off your balance. But for some reason in Hawks, it did not let you, it doesn't let you type in a decimal. So I decided to round up to 18. So 18 months. And that would be your answer. So these are really time intensive, and you should be really careful that you plugged everything incorrectly and that the answer itself makes sense, because it's going to be a pain in the butt to have to retry these solutions. Not solutions, but problems. That one's a monthly payment. Monthly payment. Oh, here it is. Okay, so this one is telling us, suppose you want to purchase a house. Your take-home pay is $4,270 per month. So I'll underline that. And you wish to stay within the recommended guidelines for mortgage amount by only spending 1/4 of your take-home pay on a house payment. You have $18,500 saved for your down payment, and you can get an APR from your bank of 5.7%, compounded monthly. Whoops. What is the total cost of a house that you could afford with a 30-year mortgage? So let's take out what we have. Our take-home pay is $4,270. We only want to spend 1/4 of that. So what I would do is times that by 0.25, and we will do that in a moment. We also have our $18,500 for our down payment, and we can get an APR for 5.7%. And if it's compounded monthly, we'll just keep that aside. And we know that we have a 30-year mortgage. So 30 here is going to be our time. This is going to be our payment. This is going to be not really actually any of our variables. We'll deal with this in a minute. So we'll draw a little red box around it. And this is going to be our rate. And we go over, we look at our formulas. We know that we have a payment. We just need to figure out what that payment is, and it shouldn't be too much work. We have our rate, we have our times it compounds, we have all the things that we might need. And also, I forgot to mention, this one also does not have a Excel spreadsheet formula, so we're gonna have to type it out. Now, yeah, I don't like it. But we'll take this and we'll go back into Excel. Ah! Whoops, hold on. I don't know, I didn't keep it configured, but oh well. So we have, just for ease, I'm going to write our variables that we have. So we have 4,270 for our monthly. We know that we want 1/4 of that. I don't know why I did that. We'll just keep it as that. Well, I don't know why it's doing that. It's fine. We'll keep it. So 0.25. And then we'll have our 30 for time, our 18,500 for a down payment, and our 5.7%. Whoops, that's a question mark. So then we'll take a field trip up to our equation, and I'll move this to the side. And it pretty explicitly says that we want to find the maximum purchase price of our house. Like how much can we afford, basically. So when we go into Excel, we'll do equals, and then we'll type in our payment, which, well, first we have to figure out what our payment is actually. So in this box, I will do equals A1 to reference the 4,270, my bad. And then we'll times it by B1, and that will give us our quarterly payments, our monthly payments. It's a quarter of our take-home pay. And then we will take that and do equals, and our quarterly payments is going to be B2, not quarterly, I keep saying that. Our monthly payments will be B2, and then we'll do multiplied, and then I'm going to put 1 parenthesis for the first one, and I'm also going to put a parenthesis around the whole thing, so it makes sure, I think that it's not necessary, but I like to do it just in case. It gives me peace of mind. So 1 minus, and then we will have parentheses, 1 plus r over n, which is, our r is 0.057, and divided by our n, which is monthly, and then we will close that parentheses, and then we will open a exponent, we'll do the up caret, open another parentheses, negative n, which is going to be 12, times t, which is going to be 30, and then close that parentheses, and then close that parentheses, and let's see, yep, and then we'll do divided by, open a new parentheses, 0.057, and, whoops, not comma, and then divided by n, which is 12, and then we'll close that, and it looks like that should cover all of our brackets. Now it's probably still going to say we have some changes. Oh, no, nice. So now we have the amount that we could take out for our loan. But if you remember, we started off with a down payment as well. So we can take this cost and we can add those two together. So, because you will be able to afford the price of this house, but you still have your down payment. And we didn't calculate that into our equation, but we need it still because that money doesn't disappear. So A3 plus B3 is going to be 202,425. Sorry, I don't know why I have so many problems with saying the numbers. Now let me go back to our equation and I'll write that down really quick. That is 22,425. That would be your answer. And that seems, well, it used to be pretty reasonable for housing. Nowadays, I'm not so sure if it checks out still. But that would be how we deal with that kind of equation. Now I'll go back into full screen and we'll go to some more of our payment problems. The rest of this video, I believe, should be only about monthly payments. Well, we'll go to this one first because it's pretty intimidating to some students. So Easton has two options for buying a car. Option A is 1.5% APR financing over 36 months, and option B is 5.5 APR over 36 months, with $180 cash back, which he would use as part of the down payment. The price of the car is $35,442, and he saved $3,500 for the down payment, and we want to find the total amount Easton will spend on the car for each option if he plans to make monthly payments, and we'll round our answers. Whoops, to the nearest cent. And let me go up one layer. So, actually, this one might be monthly. How much? No, never mind. This is still monthly payments. So, let's write down our two scenarios. For option A, and then we'll do both. So, for option A, we have 1.5% APR. For both, we have 36 months. We have 5.5 APR on B, and we also get $180 cash back. The price of the car for both is $35,442, and for both of the situations, we've saved a $3,500 down payment for the car. We want to find how much he would spend according to each option. So we'll move this to the side. This one we'll be using the payment formula first because it hints that he's planning on making monthly payments. Now, this one does in fact have a formula, and I highly recommend using it instead of plugging things into your calculator because it makes things way quicker. doesn't mess up, it doesn't throw any of the numbers around. It doesn't mess up any of the parentheses or anything like that. It's just really a lifesaver, honestly. We'll start with option A. So our rate is 0.015, and then it's going to be monthly payments, so divided by 12, comma, now remember, it's a negative NT this time. So, and it's over 36 months. So I'm going to just plug in 36. Now, what you might have thought at this point would be 36 times the number of years. Now, that isn't quite what we're thinking. The reason why we're doing just negative 36 instead of negative 36 times 3 or something like that is because this slot right here is for the NPER, which stands for number of periods. Now, the reason why we might times it by 12 and by 3 or something like that is if it doesn't give you how many months it is in. Basically, 12 times 3 is the same as 36, and both will be negative for our equation. But if you make a monthly payment, each period you make a payment and each period is in a month, it stands to reason that for 36 months, there'll be 36 periods. If that makes sense. Hopefully that makes sense. The biggest mistake I see in this part is people take the negative 36 and times it by like 3 or 12 or something like that. We just need the negative 36. And then for PV, it'll be 0. And then for future value, now, before we continue, here, let me copy this. We're going to ignore this 0. We forgot to take the down payment out. For option A, the car is $35,042. Sorry, $35,042. Yeah, I don't know. And then we're minusing the down payment out because you don't need to take out a loan for the whole price of the car if you pay a down payment. You only need to take out a loan for the amount that you do not have yet. So our rate will be $31,542, like our price of the car, which is our future value. So 31,542, and 42. And I will press enter. And that gives me $896.58 for our monthly payments. So, oh, I lost it. Oh, 896.58 for A is our payments. Now what we'll do is we will times the amount of payments that we have by 36, because that's how many, if this is his monthly payments and he has 36 months for the loan option, that means he's paid this 36 times. So we'll do 896.58 times 36, which when we plug that into Excel, so A1, we'll just do that for ease, times 36, that gives us 32,000, 32,276.72. Now remember, we still pay the down payment, so now what we'll do is we will take our total cost that we pay over the length of the loan, and we will add our down payment back, which is $3,500. So this is the price of the first car in option A. So 35,776.72. Now, for option B, we'll be doing sort of the same thing. We will take, first, again, we need to find how much we're taking out for our down payment. We have 35,000, well, let me put in equals, so 35,000 and 42, and we will minus 3,500, and we'll also minus 1,800. And the reason why we're doing that is because we'll get cash back for that, and it already says that we'll be using part of that for the down payment. So if we are using that for the down payment, we don't need a loan for the whole, for like the 32,276 like we did in the last one. we'll need a loan for the $29,742. Sorry, someone in my family just got home and my dog goes wild when they do. So for this, we'll take our payments. Well, let's stick with the format. So equals payment. And the rate is 0.055 divided by 12, because they're still monthly payments. Negative 36 again. And then 0 for present value. And then for future value, we will do the 29 and 742 for our down payment, and then we can press enter there. And that gives us 898.9. So we'll take our 898.9 and we'll do the same thing. B1, and then we will times that by 36, and then that gives us this. And now we need to add our down payment back in. So equals 32,331.11. Now be careful. What I see happen a lot, and what even I did yesterday when I was working on this, and it had been a while since I'd seen these types of problems, I initially wanted to minus the whole, 5,000 something. But we don't need to, we only need to take out the 3,500, yeah. Because we're wondering how much he spent on it. He didn't spend the 1,800 cash back, necessarily. They were giving him that money. So we don't need to minus that twice. We already took care of minusing it in the beginning when we were taking out our down. Oh, I did minus instead of add. One sec. Okay, which gives you 35,831.11. So we'll look at this, 35,831.11. Now we can look at this and we can be like, whoa, one is bigger than the other, right? So if you were doing a loan and you were in this situation where you were wondering which car to pay for, you could do this type of problem where you're like, I wonder which situation I should be a part in. So it's a small difference, but when you are saving for a car and stuff, every bit counts. So this one is more expensive, but either way, we would type in what we found for option A and type in what we found for option B. But in a personal situation, I probably would pick option A because it costs less in the long run. So now we'll go up to some of the more simple problems that are more payment. Amy bought a new car for $38,000. She paid a $20% down payment and financed the remaining balance for 48 months with an APR of 4.5%. Monthly payments. We want to find the total interest Amy pays over the life of the loan. So first, she pays a 20% down payment on the $38,000. We don't need to include that when we're working on our payment formula. Let me delete this. So we will do 0.20 times, and I have to figure out what that was again. Let me zoom out a bit. 38,000. Whoops. And that gives us 7,600. We can go to our payment formula, payment, and for our rate, it will be 4.5, so 0.045, and then it's monthly, so divide by 12. The NPER is 48 months, so negative 48, same principle as before. And then our present value is 0. And our future value is 38,000, which gives us 866.53. Now, it's not asking for the payment. It's asking for how much she pays over the life of the loan. So we will go and take what we found in A2, our monthly payment, and we will times it by the amount of months that we have, which is 48. And that will be $41,000 and 593. Sorry, sometimes saying the numbers at night is kind of tricky for my mouth. But we will take that. And then we will also take that again And we will add our down payment back because we still have, oh, wait, wait. Oh, no, we will. I don't think it matters necessarily, though. Which was our 7,600. Oops. Oh. So if she paid this much for her car, and we want to find the total amount of interest that she paid, what we can do is we can do equals, and then we can take the amount that we have for the car, A4, and minus it by the market value, the selling price. And that will give you $11,193 and 56 cents. Dollars and 56 cents. That is how much interest she had to pay over the life of the loan. It seems a little high, but it's all right. We'll just, yeah. Whoops. Yeah, everything went according to plan. Yeah, okay. So then we have another, and again, like I said, this is just us doing payment to get the hang of it. I probably won't finish this last one because I don't think I need it. So this one is telling us that Arden wants to buy a new generator. The generator costs $28,000. Arden decides to finance the generator for 36 months at an APR of 11.5%. We want to determine his monthly payment. So what we'll do is we'll go up to Excel, delete, and then equals, and then payment. And then for our rate, I already lost it. It's 11.5. So 0.115, and it's monthly payments. And then comma, negative 36, comma, 0, comma, 28,000. Well, not 28,000, 2,800. And so we'll do that, and it should be $92.33. That's how much our monthly payment is for this generator. Yep. Alrighty. Hopefully that makes sense to you. This is my longest video yet, and I really appreciate if you sat through the whole thing. But yeah, if you have any questions, please let me know. I know that this unit's a bit more tricky. But yeah, have a good day.